Today we will be looking at sine rule and its applications to solving triangles and bearing a distance. And we have this. We are using a triangle, but the triangle we are using this time around is not a right angle triangle, because it is not in all cases that we have a right angle triangle to solve. I explained during the last lesson that when the value of theta becomes greater than 90, then we cannot use SOHCAHTOA. Then that is where sine rule now comes in. When we have a triangle ABC, I explained earlier that the side facing each angle, we represent the sides with the lowercase letter, or we also call it the small letter. We have the angle A, the side facing it, we are representing that one with small a. We have angle B, the side facing angle B, we are representing that one with small b. And we have angle C, the side facing it, we are representing that one with angle C. And sine rule states that A over sine of this angle A is the same as B over sine of this angle B, and is also the same as C, which this C over sine of this angle C. Or we can also state it as sine A over A equals sine B over B equals sine C over C. Now the next thing we look at is when can we use sine rule when we come across a triangle. We have sine rule. Sine rule can be used when we are given when we have two angles and a side facing one of them. That is when we use sine rule. Or the other, we have when we have two sides and an angle. But this is not the same for cosine rule. But for sine rule, if you are to make use of sine rule, we must make sure that in the triangle we have two angles and a side facing one of them, and we have two sides and an angle involved. That is when we can use sine rule. So we have an example. In triangle ABC, angle A is 115 degrees. We are given side A, that is small a, to be 65 meters, and we are given small b to be 32 meters. And the question is, we are to solve the triangle completely. Now to solve that triangle completely, that means we have to find angle B, we have to find angle C, and we have to find the missing side A, which is side C. These are the three things we need to get to solve the triangle completely. So the first thing we do is we make a sketch of the triangle. And looking at this angle, it is more than 115 degrees. And we need to show that in our triangle. So I will label this side A, because this one A, 115, is more than 90. Then I will label this side B, and I will label this side C. The side facing this A, that is small a, and we are giving small a to be 65 meters. We are giving angle A to be 115 degrees. The side facing facing angle C is small c, and the side facing angle B is small b, that is 32 meters. So if you look at the triangle we observe that we are given two sides and the angle facing one of them. And from the conditions I gave the other time for using sine rule, I said when we have two sides and the angle facing one of them, or we have two angles and a side, we can use sine rule. So from here we make use of sine rule. Cosine rule cannot be used here because we have the conditions for using cosine rule as well, but we cannot use it to solve this triangle that we are given. So using sine rule, then if you want to use sine rule, we cannot use the 3 at the same time. We only use 2. That is, from sine rule we have a over sine A is equal to b over sine B is equal to c over sine C. We cannot use these 3 together at a time. From A, we are given angle A and we know side A. That one is complete. To use sine rule, we have to combine the complete one with the incomplete one. So from here, A is complete. We are using this. Then we have side B, but we don't know angle B. This one is incomplete. So we first get angle B. So we combine this and this at a time. A, B, and C, they are just unknowns. We can come across questions where they use X, Y, and Z. We can also come across questions where they use P, Q, and R. We can also come across questions where they use M, N, and another alphabet. So when we come across that, where we just see A, we just change it to the alphabet that are being involved in the triangle. So from here we use A over sine A equals B over sine B. We are not combining with C because we don't know anything about C yet. So when we find B, then we now use the value of angle A and the value of angle B to generate angle C from the sum of angles in a triangle. So A from A is 65. Then we have sine A, that is sine 115, is equal to B is equal to 32. Then we don't know what B is, so we have sine B. From A, the next thing we do is we cross multiply. When we cross multiply, this one we multiply this. Then this one A, we multiply 32. So we have that as 65. 65 sine B is equal to 32 sine 115 degree. Now, the angle we have here cannot be checked from the 4-figure table, but we can make it to be checkable from the 4-figure table by expressing this one as an angle in the first quadrant. I explained quadrants during our last lesson, and I said when we have something like this, I use something to represent them. I said all students take Coke from A. So this is first quadrant, second quadrant, third quadrant, and fourth quadrant. So this 115 is more than 90, but it is less than 180 degree. So that shows that it is from second quadrant. And from second quadrant, it is only sine that is positive. So from here we have 65 sine B is equal to 32 sine. From what I explained, when we have angles from second quadrant, we remove the angle we have from 180. So this is sine 180 degree minus 115 degree. Then we have 65 sine B is equal to 32 sine 65 degree. 65 degree that we have here and this 65, they are not the same thing. So please, this 65 cannot cancel this 65. So the next thing we do here, we have this as 65 sine B is equal to, if we check sine 65 from the 4-figure table, we have 0.9063. We need sine B. It's just as if we have 2x is equal to 4. If you need x from here, if you need to find x, what we do is we divide both sides by the coefficient. That is what we have beside x. We divide both sides by that particular value. So from here we need sine B, and there is a number beside sine B. So what we do here is that we divide both sides by 65, and we have 65 sine B divided by 65 is equal to 32 multiplied by 0.9063 divided by 65. 65 will cancel 65. So from there we have sine B. If you press our calculator for this, 32 multiplied by 0.9063, that will give us 29.002 divided by 65. And from there we have, if you divide 29.002 by 65, that will give us 0.4462. And during our last lesson, as I said, if you have to find an angle, like for instance, if you are given that sine 30 is equal to 0.5, and they ask us that if, and we are being asked that if you have sine 0.5, or we have sine A to be 0.5, I explained that we go to our four-figure table and we check the nearest value to this 0.4462. Like for this one, if you go to our four-figure table to check, we see this 0.5 in 30 under 0. So this one too, if you open our four-figure table under sine of angles to check for the arc sine, I said arc sine is the same thing as the inverse of sine. So from here we have taken arc sine of 0.4462. We have B to be arc sine of 0.4462, and from our four-figure table we have the value of B to be 26.5 degrees. So which means if you check our four-figure table for sine of angles, this 0.4462 will be seen under 26. It will be from 26 under 5, and we have this angle B, which is this angle we are having here, 26.5 degrees. Since we already have the value of A and B, then we need to get C, and from here we have the addition of angle A plus angle B plus angle C will give us 180 degrees. And the reason for that is sum of angles in a triangle. So A is 115 degrees and B is 26.5 degrees. Then plus C is equal to 180 degrees. So if you add this, we have angle C plus, this is 5 and this is 1, this is 4, and this is 1 degree, is equal to 180 degrees. Then C from here, if you collect like terms, we move this one to the other side, and by the time addition sign is crossing the equality sign, it will turn to subtraction. So C will give us 180 minus 141.5 degrees. Then C will give us 38.5 degrees. That is what angle C is. I explained earlier that to solve this triangle completely, that means we have to find angle B, which we've calculated. We have to find angle C, which is all we have here. Then the last thing to do here is to find side C. And since we already know what angle C is, we have 38.5. Now, if you look at this triangle, I said something earlier as well, that we combine the complete one with the incomplete one. So from here, we can combine A and C, or we can, since our B is also complete, we can combine B with C that is not yet complete. So we also go back to sine rule. Using sine rule, we have B, let me use A. We have A over sine A is equal to C over sine C. And our A is 65, so we have 65 divided by sine 115 is equal to C divided by sine 38.5 degrees. So from here, if you cross multiply, C we multiply sine 115, while 65 we also multiply sine 38.5. So we have C sine 115 degree equals 65 sine 38.5 degree. And we are looking for C, but there is something that is besides C which is disturbing C, and that is sine 115 degree. So what we do here is that we divide both sides by sine 115 degree. So we have C sine 115 degree divided by sine 115 degree equals 65 multiplied by sine 38.5 divided by sine 115 degree. So sine 115 will cancel sine 115, and we have C to be 65 multiplied by sine 38.5 divided by sine. From here, to check this sine 115 from the fourth figure table, we have to remove it from 180, and we have C to be 65, then sine 38. If you go to our fourth figure table, sine of angles, if you check 38 under 5, we have 0.6225 divided by, this one is sine 65, and C from there will be 65 multiplied by 0.6225 divided by 0.9063. And if you press our calculator for this, we have the value of sine C to be 44.6 meters. But because we have A and B to the nearest whole number, we also approximate this one to the nearest whole number. And if you do that, since the number that is after the decimal point is 6, and from approximation, when we have numbers from 0 to 4, they will be rounded down to 0, but numbers from 5 to 9, they will be rounded up to 1. So this 6 here, since 6 is more than 5, it will become 1, then we add down 1 to this 4, and we have C to be 45 meters. Now, I explained the combination of A and C, and we are able to obtain an answer for C as 45. But another way of doing it is using the combination of B and C. But you don't need to do the two at the same time. You can choose combination of A and C, or you can also choose combination of B and C. Then if you are choosing B and C instead of the combination of A and C that we have used the other time, this is the outcome. This is what you have. You have B over sine B equals C over sine C. And B from A is 32. We have 32 divided by sine of angle B, which is 26.5, equals C, which is the side we are looking for, divided by sine of angle C, which is 38.5. And the next thing to do from here is to cross multiply. So by cross multiplying, this one will multiply this, while this will multiply this. So we have C sine 26.5 equals 32 sine 38.5 degree. And what we need here is C, but we are having a particular value that is disturbing C, and that is sine 26.5. So what we do here is that we divide both sides by sine 26.5 degree. So we have C sine 26.5 degree divided by sine 26.5 degree equals 32 sine 38.5 degree divided by sine 26.5 degree. So this will cancel this. And if you check our four figure table from here, sine of angles, you check 38 under 5 Then from there we have C to be 32 multiplied by 0.6225. Also, if you check sine of 26 under 5, we have 0.4462. And if we press our calculator for the product of 32 and 0.6225, that will give us 19.92 divided by 0.4462. And C from A is 44.6 meters. But because the other ones are in the nearest whole number, we have C to be, this is 6, and 6 to be rounded up to 1. So the addition of that 1 to this 4, we make our answer to be 45 meters. The combination of A and C to find side C gave us 45. And the combination of B and C also to find angle C, to find side C, is also giving us 45. If you are using any of them, you must make sure that you have the right answer that you are meant to have. Maybe when you are practicing or when you are solving questions, you can try to use the two. And when the answer in one is different from the answer in the other one, then you have to trace the step back. Possibly there has been a mistake that has occurred during the calculation. So, but the two will give us the same answer. In an exam situation, after using the A and C approach, if you still have more time in an exam situation, so you can just check to know if the A and C approach has given you the right answer by using the B and C approach, which you don't need to state, which you don't need to solve in your answer booklet in an exam hall. But you can just do it to cross-check if the answer is right. Now we have another example to verify the second condition for using sine rule. So from A, we have two angles and a side. And from the conditions I gave earlier, I said we can use sine rule when we have two angles and a side, or when we have two sides and the angle facing one of them. We have angle B and we have angle C, but we don't know what angle A is. And I explained earlier that we use sine rule by combining a complete side and angle with an incomplete one. So we are given the properties, we are given the steps needed to generate our angle A from A. So we have angle A plus angle B plus angle C is equal to 180 degree. And the reason for that is angles in a triangle. Angles in a triangle is equal to 180. So we have A plus B is 41 degree plus C is 84 degree equals 180 degree. Then we have A plus 125 degree equals 180. By collecting like terms, we move this one to the other side. Then we have A to be 180 minus 125. So A will give us 55 degree. So this angle A is 55 degree. I have to calculate angle A first because I must combine a complete side and angle with an incomplete one. From here we have angle C and angle B, but we don't know what angle A is. But we still need to calculate angle A so that A can be complete. So that was why I went through this to calculate the value of angle A first. Now, after this, the next thing is to proceed to what they are asking us to calculate, which is side C. Since A is complete, we just use sine rule. Using sine rule, we cannot combine B with A because they are not asking us to find side B. We are combining A and C because A is complete and they are asking us to find side C, but we know angle C. So we have A over sine A equals C over sine C. And the value of A here, side A is 7.4. Angle A is sine 50, that is 55 degree. Then C is the side we are looking for, and we have side C to be 84 degree. The next thing to do from here is to cross multiply. When we cross multiply, C will multiply this, then 7.4 will multiply this. So we have C sine 55 degree equals 7.4 sine 84 degree. Now we are looking for C, but there is a coefficient or there is a value that is disturbing C. And what we do here is that we divide both sides by sine 55 degree. So we have C sine 55 degree divided by sine 55 is equals 7.4 sine 84 divided by sine 55 degree. So this will cancel this. Sine 55 will cancel sine 55. So we have C to be 7.4. Now if you go to our four-figure table, sine 84, we check under sign of angles, 84 under 0. And that will give us 0.9945. Then we also do the same thing for 55. We check from sign of angles, sine of 55 under 0. That will give us 0.8192. And if you use our calculator, C will be 7.3593 divided by 0.8192. And if you divide the two, we have C to be 8.98 meters. And that's the answer to that. We have another example, but this example is on the application of sine to bearing and distance. The question says a tree is on a bearing of south 46 degree west. And this type of bearing, from what I explained, I said this is what we call compass bearing. South 46 degree west from a point X. We should take note of that word, is very important. That means the bearing is to be taken from X. And that same tree is on a bearing of south 58 degree east. This is also a compass bearing from a point Y. If X is 300 kilometers due east of Y, calculate the distance of the tree from Y to the nearest meter. Now we start by taking the first one from X, southwest. From our four cardinal points, this is north, this is south, this is east, and this is west. So we are looking at southwest. So we start by drawing this. We have X. From X, south 46 degree west. So we take it from the south pole. Then this is 46. We have this line. And that same tree is also on a bearing of south 58 degree east from a point Y as well. But X is 300 kilometers due east of Y. Due east of Y. Since this is the eastern direction, if X is 300 kilometers due east of Y, then we can also put that Y is 300 kilometers due west. So Y will be on this side because the eastern part of Y is towards this direction. Then the place where Y is to X, that is towards the western part of X. So we have this as well. This is Y, and this is due. So this is Y, and this is south 58 degree east. This is east, and this is south. So 58, we have it like this. So this is the position of the tree that we are talking about. The tree. So this one is 56 degree, and this one is, sorry, this is 58, and this one is 46 degree. The distance between this and this is 300 meters. Now from there, the next thing we need to do is to get the value of this angle A. We have angle Y from there. We know that when we have a quadrant, I said this from A to A, the angle there is 90. Also from A to A, the angle is 90. But we are given the angle from A to A as 58. Then we need to get the remaining one. That will be 90 degree minus 58 degree. The reason for that is right angle. So it means we have angle Y from there to be 32 degree. So this is 32 degree. Also for X, angle X from there is also 90 degree minus 46 degree. The reason for that is also right angle. So X from there will be 44 degree. So which means this angle A is 44, that is 44 degree. So after getting Y and X, we observe that we have angle Y and angle X. We don't know what side X is. This one is side X. We don't know what side Y is. But we know what side T is because we are representing that one with capital T, because this point is talking about the tree. And the question is asking us to find the distance between Y and that tree. That is what the question is asking us to find. But there is no how we can get this without getting the value of this angle. Since I explained that for using sine rule, we combine the complete one with the incomplete one. So we need to find angle T from there. This is a triangle, and we know that the sum of angles in a triangle is 180 degrees. So we have X plus Y plus T equals 180 degrees. That is sum of angles in a triangle. X is 44, Y is 32, but we don't know what T is, equals 180. So the addition of this will give us 76 degrees plus T equals 180 degrees. And if you move this one to the other side, we have angle T to be 180 minus 76 degrees. So which means T is 104 degrees. Now we know all the angles. T is complete, but we need to find X. So we are combining T and X, because the side we are asked to find from the question, we are representing that one with X. We don't need to find Y because the question is not asking us to find the distance between X and the tree. From there, using sine rule, we have X over sine X equals T over sine T. We don't know X, that is what we are looking for. We have X divided by sine 44 degrees equals 300 divided by sine 104 degrees. By cross multiplying, you have this. 300 will multiply this, while this X will multiply sine 104. So from there we have X sine 104 degrees is equal to 300 sine 44 degrees. We are looking for X, but we are having sine 104 as the coefficient of X. So it means what we do there is we divide both sides. by sine 104 degree. We have x sine 104 degree divided by sine 104 degree equals 300 sine 44 divided by sine 104 degree. Then we have x to be, this 104 is more than 90, but it is less than 180 degree. So that is from second quadrant. And what we do there, we have this as 300 sine 44 degree divided by sine 180 degree minus 104 degree. And x will be 300 sine 44 divided by sine 76 degree. So from here, if you check our four-figure table, we have x to be 300 multiplied by, if we check sine 44 from the four-figure table, that is 44 under 0 from sine of angles. We have it as 0.6947. Then if we check sine 76 as well, we have 0.9703. And the product of this will give us 208.41 divided by 0.9703. So x from there will give us 214.8 meters. But there is an instruction in the question that we have to express our answer in the nearest meter, and that is approximation. We go to the digit after the decimal point, that is 8. And I explained earlier that digits from 0 to 4 will become 0, but digits from 5 to 9 will be rounded up to 1. And this is 8. So 8 will become 1, and by adding that 1 to this 4, we have the value of x to be 215 meters. And the reason for that is nearest meter. So this is giving us the distance between y and the tree that we are talking about in the question. Now we have another example which says P, Q, and R are arranged sticks. And the arrangement is, we have P to be 10 km north of Q. The bearing of R from P is 233 degrees, and the bearing of Q from R is 097 degrees. Then we have to find the distance of R from P. To interpret this, we take it a step at a time. We cannot combine everything together at once. So we start with the first thing that we have here. P is 10 kilometers north of Q. That is, from Q, P is due north. So the first thing we do is we draw our 4 cardinal points. This is Q. North, this is the north direction. So this is P now. And the distance between them is 10 kilometers. That is what the first statement is saying. Now, the bearing of R from P. There's another stick R, but the bearing of that R from P. So we take it from P. That is 233 degrees. And from 4 cardinal points, I said if you are given a bearing like this, I said that is a bearing in surveyor's form. And bearing in the surveyor's form is taken from the north pole. This is the north. And we are going from this north, which is 0 degree, to 233 degrees. And by moving like this, we have covered 90 degrees, 180 degrees, then we have 233 degrees. A. This is where R is, and the bearing from A is 233 degrees. Now we also have the bearing of Q. Q from R. From R is 97. So which means we have to take that bearing of Q from this point R. So this is, we also take it from the north, 097. That is talking about surveyor's bearing. So we take it from the North Pole. This is 90, then 7. This one, everything like this is 97 degree. That is 097 degree. Now the diagram is appearing as if we don't have any angle. We are the one to get all the angles. So it is after getting the angle that we now know which rule is applicable to the triangle. From here, everything like this is 233. But from here to this place, that is 180. So to get the angle A, to get angle P, we have 233 degree minus 180. It's just as if you have a line like this, and we have that for this line, from this place to this place is 10, for instance, and the whole length is 30. What is the remaining length? We just subtract this one from 30, and that will give us this. So the same thing we are doing here, from this place to this place is 180, because that is angle on a straight line, or we can also call it the angle in a semicircle. When we divide the circle into 2 equal parts, that is what we are having here. That is 360 divided by 2, which is 180. So the removal of 180 from 233 will give us 53 degree. So which means this angle A is 53. Now there's another thing again that we can do from here. There are 2 ways of getting the angle of R that we have here. The first way is this angle 53 which we have here. We have a Z angle. I explained earlier that it is alternate angle. As this angle A is 53, this angle A is also 53. As this place is 53, this place is also 53, because if you look at that, we have something like this. This, like this, like this, which is just something like this. This angle and this angle, they are equal because we call them alternate angles. So if I denote this one with theta now, theta is equal to 53 degree. And the reason for that is alternate angles. But we are given that from A to A is 97. So to know the remaining one, since we know this to be 53, the remaining angle there, which is angle R, is just 97 degree minus 53 degree. And that one will give us 44 degree. When I was taking the bearing, I took it clockwise, and that's because we are dealing with surveyor's bearing. I said for surveyor's bearing, the movement is from the North Pole clockwise. So we have to take it clockwise, not the other way around, not anti-clockwise. Now if you look at what we have here, we have R to be complete. The side facing this angle R is small r. The side facing angle Q is small q. The side facing angle P is small p. R is complete. The question is asking us to find the distance from R to P, and we have denoted that one with small q. So the question is asking us to find the value of small q. So which means we combine this one that is complete with this one that we are looking for. But there's something we need to do here before we go to sine rule. We have this angle, we have this angle, and we want to get this. So that means we need to calculate this angle Q that we are having here, and that will be done by using the sum of angles in a triangle. So we have P plus Q plus R equal 180 degree. Sum of angles in a triangle. When we are writing these things, because this topic is an aspect of geometry, whatever we write, there is always a reason, or we call it a theorem, that is supporting what we are writing. There is a theorem in mathematics that says sum of angles in a triangle is equal to 180. So that is why we are able to add these three and get 180. Don't write this thing without putting the reason for that. So from here, P is 53, Q is what we are looking for, then R is 44, equals 180 degree. So we have Q plus 97 degree equals 180. So by moving this one to the other side, we have Q to be 180 minus 97 degree. Then the value of angle Q is 83. So this angle is 83. Now we have all the angles, so we can combine the complete one, which is R, with the incomplete one that we are asked to get. That is small q, together with angle Q that we've calculated here as 83 degree. So from there, by using sine rule, we have Q over sine Q is equal to R over sine R. I explained this when we started, that it is not in all cases that we use A, B, and C. We work based on the alphabet or based on the unknowns that we are given in the question, or we work based on the variables that we are given in the question that we are to solve. So from here, A, B, and C has changed to P, Q, and R from A. It can also change to X, Y, and Z. So from here, the value of Q, we have Q divided by sine 83 degree. The value of R is 10 divided by sine angle R from there is 44 degree. From this stage, the next thing to do is to cross multiply. By cross multiplying, we have Q sine 44 degree is equal to 10 sine 83 degree. We need Q, but we have a coefficient for Q, that is sine 44. And what we do there is that we divide both sides by sine 44 degree. So that will give us Q sine 44 degree divided by sine 44 degree equals 10 sine 83 degree divided by sine 44 degree. Sine 44 will cancel sine 44. Then we have Q to be 10. If we check our four-figure table for the value of sine 83, we check 83 under 0 from sine of angles. That will give us 0.9925 divided by 0.6947. And if you use our calculator for the product of this, we have Q to be 9.925 divided by 0.6947. And using our calculator as well, we have the value of Q to be 14.3 kilometers. Then we can write our conclusion that therefore R is 14.3 kilometers from P. And that is the solution to that question.